In life, we can all make mistakes. After all, it's a human situation. So, can a genius like Albert Einstein make mistakes?
I believed in it when I was your age. Trust me, I knew everything. But as it turns out, I was wrong.
It's the year 1915, and Albert Einstein published that famous theory he had been working on for a long time, the theory of general relativity. This way, he gained a better understanding of the structure and dynamics of the universe. That's exactly why this theory is considered one of the cornerstones of modern physics. According to the theory of general relativity, massive objects bend the fabric of space-time, and this bending is perceived as gravity. With this theory, we were able to explain many phenomena, such as gravity, black holes, gravitational time dilation, and the expansion of the universe. For example, now know much more about the existence of black holes and how they form. Black holes bend space-time so powerfully that even light can't escape from this bending. Thanks to the theory of general relativity, we discovered that time passes more slowly near massive objects. This phenomenon is called gravitational time dilation. This concept is very important for GPS devices today because GPS satellites experience less gravitational pull while orbiting the Earth. That's why clocks run faster. GPS devices rely on the timing of satellite signals to determine our location. If this time difference hadn't been corrected, these devices would have calculated our location incorrectly. That's why these systems use the theory of general relativity to correct this time difference and make accurate location calculations. Now in this video, I'm going to focus specifically on one of these phenomena, the expansion of the universe. Because Einstein thought he made a big mistake in this regard. Whether it was a mistake or not is a somewhat controversial topic in the scientific community. But before we get into that, let me share some information to better understand what Einstein referred to as that mistake. Of course, there were theories about the expansion of the universe even before Einstein. The English physicist Isaac Newton introduced the theory of gravity in his work titled Principia Mathematica, published back in 1687. According to Newton, gravity is pulling all objects in the universe towards each other. Okay, it pulls. But how does this gravity work? So, are we just talking about force between two objects? Or are there other things involved? That's how we understood the mechanism of gravity with Einstein's theory of general relativity. Newton believed that space and time were independent of each other. Einstein, on the other hand, considered space and time as a whole and defined it as a four-dimensional structure. So, three-dimensional space plus one-dimensional time equals four-dimensional space-time. According to the theory of general relativity, massive objects can bend this fabric of space-time. For example, a massive star like the Sun bends space-time, which is why planets move along this curvature. So, gravity arises from the bending of space-time, and objects follow these curved paths in space-time. So, gravity rises as a result of the bending of space-time, and objects follow these curved paths in space-time. So, according to Newton, when an apple falls to the ground, gravitational force between the Earth and the apple pulls the apple down. According to Einstein, the mass of the Earth bends space-time, and as the apple falls, it's actually moving along this bent path. So why did I explain all this? Because all of this is related to the topic of the expansion of the universe. So, there's a connection to what Einstein described as that mistake. So why did Einstein think he made a mistake? Because when he developed the theory of general relativity, the accepted view in the scientific community was that the universe was static, meaning it was unchanging. However, with our current knowledge, we know that the universe has been expanding since the Big Bang. But back then, Einstein also believed that the universe was static. That's where he saw a problem, because these equations dictated that the universe should be expanding or contracting. So how can the universe remain static? To solve this problem, Einstein added a term to his equations called the cosmological constant. If we're going to accept the static universe model, we need something to stop the universe from expanding or contracting, right? So, we need a pushing force to keep it balanced. According to Einstein, the cosmological constant was exactly what was needed, this. So it functioned, like a sort of anti-gravity, until discovery of astronomer Edwin Hubble in 1929. At this time, Hubble discovered that galaxies were moving away from each other and that the universe was expanding. This discovery disproved Einstein's idea of a static universe, and showed that the cosmological constant was unnecessary. Einstein called this the biggest mistake of his life. After Hubble's discovery, research on the expansion of the universe gained momentum. In 1998, two independent research teams, observing distant supernovae, discovered that the expansion of the universe was accelerating. This discovery caused a huge stir in the scientific community, because until that day, it was thought that the expansion of the universe would slow down over time. There's a very simple reason for this way of thinking. According to general relativity, if massive objects are attracting each other, then this gravitational force should also slow down the expansion of the universe, right? If the universe has been expanding since the Big Bang, then it needs some kind of energy to keep that going. So we need more energy than gravity. What happens if that energy isn't there? Gravity slows down the expansion over time, but that's not what's happening. The universe is continuously expanding at an accelerating rate. So scientists have thought and thought, they just couldn't find the source of that energy. They call it dark energy. According to observations, dark energy makes up about 8% of the universe's total energy. The remaining 27% of the universe is made up of dark matter, and only 5% consists of the normal matter we know. So, is the density of dark energy constant? Cosmological observations, like supernova observations, support the idea that the density of dark energy is constant. Of course, there are some theories suggesting that this density could change over time, but for now, the accepted view is that dark energy has the same density at every point in the universe. So it has a constant density. Does the word constant sound familiar to you? Look, you remember? So, what initially seemed like a mistake may not be a mistake. Today, dark energy resembles Einstein's cosmological constant. This constant accelerates the universe's expansion. Because today, when we look at it, dark energy shows an effect very similar to Einstein's cosmological constant. We can think of this constant as a force that accelerates the development of the universe. This is really a very interesting topic. That's why I'm curious about your opinions too. Was Einstein really wrong? Or did what he defined as a mistake contribute to today's concept of dark energy? You can write in the comments. If we are going to look for a mistake in Einstein, we might say that he acted according to the generally accepted view of his time. So, he added a cosmological constant to his equations based on the view that the universe is static. Actually, this inductive approach is a method that's frequently used in scientific research and often leads to correct results. However, the initial wrong assumption led to a specific mistake. But isn't that how science progresses anyway? So every new finding vises the old theory. I think the main point here isn't whether Einstein made a mistake or not, but that he accepted the mistake.
What anomaly? My God, you're right.
We're talking about Einstein, not an ordinary person. He dedicated his life to all these theories and equations, one of the smartest people in history. Just think about it. He honestly accepts his mistake without twisting or turning it. Moreover, even though it might not actually be a real mistake, because today, what we call dark energy is essentially the cosmological constant itself. What we call science progresses through observation and experimentation. Scientific methods and assumptions are constantly evolving. Mistakes play a huge role in this progress. That's how important it is to make a mistake. But even more importantly, it's about accepting that mistake. Even though Einstein described the cosmological constant as a mistake, it didn't tarnish his scientific reputation. On the contrary, his courage to accept his mistakes showed that he was a humble and realistic scientist. This was seen as a sign of how great an intellect he was. The evolution of science and the evolution of intelligence both happen thanks to those mistakes. We all make mistakes. In our work, in our personal lives, in every area of life. But those mistakes always push us forward. Because the best way to learn is to make mistakes. So if someone asks you who the biggest teacher in life is, you can confidently say, my mistakes.